It's wonderful to be here. Like Marcus said earlier, we're happy to collaborate with Codon on both open source and AI and all of this good stuff. There's going to be a lot of open source throughout my presentation. In fact, pretty much all of it is going to be open. But that being said, we are building a company around this. We are at Berget AI, we are building European AI infrastructure. And so that means that we're European first, no data goes outside of Europe. And all our data centers are in Sweden. So you can trust that your data stays here. And that matters for a lot of people, as we will see. And to start off, I just want to ask how many people in here are actively working with like a coding assistant, like Claude Code, Codex, just hands up. Yeah, yeah. So wonderful, wonderful. I'm in the right crowd, I can tell. So the tricky thing with coding assistants like Claude Code is that it's really smart, and that's I'm saying that both as a good thing, but also as a potential risk, because these agents, they tend to find things that they're not intended to find, right? If you have SSH keys, it will try to find them and log in if it think it needs to. If it has access to a password manager, it might try to look into there and see what's available. You know, everything in order to achieve its purpose or the goal it's working towards, right? And that can be a risk. Let's say that you're working in a very regulated industry. You might have a database, you know, consisting of sensitive information. You know, could be healthcare information. It could be personal information, and so on. And you might not be allowed, for compliance reasons, to send that off to the US, for example, or any other provider for that matter. So that comes with a challenge. And I'm saying, you know, US here, and I'm not sure if you've seen this recently, but the US government is really pushing against data sovereignty these days. And that kind of makes you wonder, why are they interested in not in Europe not having sovereignty over your own data? Why is this so important to them, right? You can understand that companies like OpenAI or Anthropic, they would, you know, fight against it because they want the customers. So why does the US government fight so hard against this? Well, because it's a benefit. You know, they have all this information and it's available to them, right? I'm not sure if you're aware of these, you know, regulations, but in the US, they have something called the Cloud Act, which essentially means that no matter where data is located in the world, the US government has the right to demand access to it. So it doesn't matter if your data is in Frankfurt, if it's in, even if it's in EU North 1, it doesn't matter. The US government has legal right to access that data. And same thing goes for FISA 702, which allows the NSA to collect this information of or any communication that goes inside U.S. infrastructure for non-U.S. people. And that means Swedes. That means all Europeans. The U.S. is legally allowed to collect this information. So why does this matter for us? You know, obviously the U.S. is collecting this information, and it's very beneficial for them, you know, for intelligence reasons and other. So data residency is not data sovereignty. Data residency is where the data is located. Data sovereignty is who has control over that data, right? So if the company that controls your data is incorporated in certain countries, say US, that means that the US laws apply to that company, right? So that is why these two things are different and why that matters. And we believe that in Europe, we need to have access to sovereign alternatives for mission critical you know, systems, AI and infrastructure like it. But you might say, oh, I really like my Claude Code. I can't go back. I'm bit by the bug. I can't go back. This is how we do software these days. and you wouldn't be alone. Software developers all over the world feel this way. There's just no going back. It's just so powerful. It finds bugs that I would never have found otherwise. But it comes at a cost, of course. I'm here to tell you today that there are options. These proprietary models developed by Anthropic and OpenAI, they're not the only ones. There's a huge market now for open models. And by open models, I mean models that you can run yourself if you want to. You can download them, you can put them on your computer, you can run them yourself.
So Marcus, can you close the...
Oh yeah, thank you. One of them is the GLM 5.1 that released very recently. Incredibly powerful open model. And as you can see from the graphs, it is very much on par with the frontier models that you're all using. So open models used to be kind of far behind the frontier models in pretty much every way. That is just not true anymore. If you haven't tried an open model these days, I encourage you to do it because it is more capable than you might think. And they're not just getting caught up, they are getting smaller. That's the benefit of working in an open source capacity, where you can have a lot more eyes looking at this, working on getting these smaller, more capable. One such example is the open model that Google actually released recently called Gemma 4. And Gemma is a very interesting model because it's an incredibly powerful model, as you can see on this y-axis. It's an intelligent model, but it's a very small model compared to other models that are up here that are incredibly powerful, but they're much, much bigger, which means that they're more costly to run. So there are a lot of things happening in the open model ecosystem, and I feel like new models are coming out like every other week. So as a company that are hosting open models, that's a challenge because we want to stay up to date, but so much is happening here, and every model that comes out is just like, ups the ante of what's possible. And of course, Claude Code, the power comes from having an interface of working with code. And I want to highlight one of those options for the open source ecosystem called OpenCode. So OpenCode in the terminal looks very much like what you would see in Claude Code, works very much the same. And they also have a desktop application, albeit in beta. I'm using it myself, and I really like it. Sure, there are a few glitches here and there, but if you really want to have a stable experience, I would definitely suggest the terminal application. We're going to see this in a little bit. I'm going to do a demo. So we're looking at, we see that we have the need to build European AI infrastructure today. And we also have the means to do it. We have the open models. We don't have to train our own, today at least. There are benefits of training our own on like specific Nordic cultures, for example. Not all American models know what the almond in the porridge for Christmas means, who gets the last cookie on the table, and so on. These like Swedish or Nordic culture that is just not encoded in the American models. But substantial work is being done on that, so I'm very curious to see. But so we have these open models, and we have to do it. What is stopping us? Why aren't we doing this today? Well, the challenge is running these open models, right? Just because they're open and available, you can download them, doesn't mean that anyone can do it. Especially these powerful ones. I would say the GLM 5.1 that I just showed you, you can see it here on Hugging Face, which is a website where companies publish their models, and you can look under files here, for example, and it's very small here, but you can see that it's 1.5 terabytes, in size. And you might think, well, I mean, my hard drive is much bigger than that. I can store that, sure, but this has to be in your memory, like your RAM, and you need to load this into your your memory, not on their hard drive. That's the challenge here. And I don't know about you, but I certainly don't have that much memory on my laptop. I might have like 32 gig, or if I'm lucky, 64, but certainly not terabytes. So this means that it's prohibitively large to run yourself. But as we will see, there are other models that you can run yourself. But that means that in order for us to be competitive in Europe and compete with these frontier models, that means that we need to be able to run these larger models as well, right? They're capable, but they demand a lot from your hardware. But let's start a little earlier than that. Let's hold off on these large models. Let's see what we can start off with. So if you are interested in starting out with open models, I think that you should get acquainted with these three options. And they're ordered here in terms of how approachable they are. So if you haven't done any work with local models before, I would say that start with Ollama. Ollama is designed to be easy to set up. It handles a lot of technical stuff for you. You just load a model and you're up and running. Llama CPP is when you need a little bit more control, when you want to start fine-tuning for your hardware, when you want to squeeze out a little bit more performance. But these two options are not really designed for scale. For scale, you want to look at something like VLLM. In fact, that's what we're running at. And VLLM is designed to run, to serve multiple concurrent users at scale. So that's the difference here. But if you want to just get started with open models, try Ollama, or as I will show you next, you can start even simpler on your laptop today with an open source tool called Jan, which is really cool. It's a desktop application, and I wanted to show you what it looks like. So Jan AI is designed to work with local models or open models. And it looks just like any other chat application, except that you have here a kind of a marketplace or a hub for all open source models that they have selected here. I've only downloaded one for this demo, a small version of the Gemma 4 that we will be trying out. And if I disable that again, you can kind of see here that you have like the size requirement here. So depending on what capabilities your laptop have, you can find the model that works for you. So yeah, obviously there's a few of them that are a little bit bigger and more capable. Experiment, see what you can fit on your laptop. But once you have downloaded one, it will work just the same actually. So hello, and this is a 4 billion parameter model from Gemma 4. They have a bit bigger models as well, but this one is designed to work on more edge and computers that have less resources available. You get 31 tokens per second. It's definitely workable on my laptop, as you can see. If you're looking for a chatbot, if you're looking for some basic chat capabilities, this is perfectly fine. But obviously, if you're looking for something more capable, like an alternative to Opus, for example, this just won't cut it. So you need a lot more power for that. And that's where one of our founders started out a year ago, where he thought that, okay, we want to start running these larger models. How hard can it be? I just get a computer and start running it, right? So he actually had access to one of these through the company he was working at, and it was just sitting around. So he thought, well, let's fire it up and see what we can do with it, right? So he installed like a Kubernetes cluster, got things rolling, and then he sent an email to AMD because he realized that, well, we're going to need a lot of powerful GPUs in order to do this. And And obviously, NVIDIA is, at the forefront. But maybe, if you at AMD want to give us a suggestion, maybe, an offer GPUs, we can certainly consider it. How expensive can it be? It's just GPUs, right? Well, it turns out it can be very expensive. So, but we bought it, and we invested, and we think this is important. So now we're running one of these suckers in our data centers, right? And this is what it looks like. So this is a very custom piece of infrastructure, and this is what you're looking at if you want to run these more powerful models in production. And as you can see, this is what it looks like when you own your infrastructure. Personally, I've been, ever since I started my career, I've been running on, cloud compute, virtual servers in the cloud, right? It's definitely an experience of going in and seeing the hardware that you're actually running on, all the cables and the metal that sits behind all of this. So it's very exciting stuff. So yeah, let's look at what this could look like when you're actually coding. So I'm gonna switch to OpenCode here. I think you can see it. So this is one of my open source projects. I want to see if the GLM can find some bugs in it. And if you're using Claude Code, this looks very familiar, I'm sure. Both the interface and what it reads your files. It has tool calling. It can search the web, research bugs, and so on, right? And it works just like you would expect. The difference that I find pretty interesting is compared to Claude Code, you can create your own primary agents. In Claude Code, you can create sub-agents that do specific things, but you can create your own personalities here. For example, here I've created a primary agent called Gordon Ramsay, and I'm gonna have him review some of my recipes here. So, hey, Gordon, what do you think about my hummus? Right, and you can obviously, if you have certain requirements, behavior that you care about, you can encode this into your own agents, right? Okay, he's not a fan, but he has some suggestions at least. So OpenCode is very much a viable alternative. You can switch to a variety of models. Another one we have is the GPT OSS 120p, which is great for reasoning. If you're want to review maybe meeting notes, summarize and stuff like that, that's highly capable. Maybe not necessarily a coding model, but yes, definitely check it out as well. So here we can see that it's let's see. Yeah, he found some potential bugs here. It doesn't look good for me. I'll sort these out later. But absolutely, let's continue. So as you can see, running AI infrastructure today, local models, open source software all the way, VLLM for serving it, open models available to download for anyone, open source coding assistants that are highly capable. You are now able to run an entire AI infrastructure coding experience completely open source. This was not the case a year ago, I would argue, but it very much is today. And I argue that this is where we're heading. We talked a little bit earlier today about being able to switch out these models and infrastructure. And the benefit of serving these local models is that they are all served behind an OpenAI compatible API, which means that anything that supports OpenAI also can serve all of these local models. So very exciting stuff. that's all I have for today, but I'm more than happy to answer questions. If you have any other questions about local models, open source, what we do at Berget AI, and so on. Thank you so much.